David Lewis, 50 or higher level maths, 3D problems in trigonometry, part 1. Okay, in this video what we're going to be doing is going to be building on the tools we've learned over the last number of weeks, not so much in functions, but the tools that we have learned in right angle triangles. Now you will remember that I got you to do page 1 to 45 of basically junior cert trigonometry, and I said you needed to know that inside out, and the whole reason for that, I wanted that to be second nature, was for these ideas that we're going to do here now in a second. Now these are quite straightforward as long as you follow a plan and you're okay with SOHCAHTOA and Pythagoras. So we should be alright with that. We should be willing to follow a plan. If you don't follow the plan, it can be quite hard to spot even what the examiner is looking for. So if you open up your notes on page 48, you can see 3D problems here. There was a 3D problem in last year's paper, but they actually got us, it was quite difficult, they actually got us to sub in for X, and it was something to do with a cuboid, but that's something we're going to build up to, and I wouldn't suggest that was very well received. This stuff can be very straightforward, and it can be used to separate yourself from other candidates in the leaving cert. So, anyway, it says, another type of question the examiner can ask involves problems in 3 dimensions. Great. Now, what we're actually going to do with that 3 dimension, if you want to write that in there, is we're going to turn all our 3-dimensional problems into 2 dimensions. We're like, if you can see the diagrams behind me at the moment, it's quite hard. Like, I am not good in 3 dimensions. I am not an engineer. Okay, so it took me a while to draw that up, and it took me a while to draw that cuboid. But it is nothing about that. We're going to take that and go back and make it easy, back to junior cert, back to 2-dimensional sort of stuff. That's the whole crux of this. Questions like this will involve working with and solving triangles as before, but the triangles can be difficult to visualize when they are arranged 3-dimensionally. The best way to deal with this is to make a simple sketch of the separate triangles you're working with, and to make it easier to see what you've been given and what you've been asked to find. So they can ask you about boxes, you can see there, parts of a cuboid, wedges and pyramids. Okay, now pretty much all of these are going to be right angle triangles. You just have to work on spotting them. Now, how I spot them is I used to follow these 2 ideas here, and I'm going to show you my 3-step plan. It's all about, in the question, drawing the piece as if you're looking at it from above, as if you're in a helicopter above the situation, looking down. What do you see? Okay, usually what you see is a square. Okay, so forgive me if this doesn't turn out to be a square. So a square or a rectangle, usually. Okay, so that's actually fairly straightforward, because we know in a square and a rectangle that there are right angle triangles, and what always comes into play on the base of these is Pythagoras. If you had 2 sides of this rectangle here, I'll just make it up, let's just say this is 3 and 4, you can use Pythagoras to figure out that this diagonal across here is 5. And that's the same with the square. They also bisect each other, as you'll remember from junior cert, and as we'll actually see and make use of in our next video. But step 1, always draw from above. And then, if possible, sketch out the shape, the triangle shape, or like the actual triangle from the piece that you are looking at in the question. So try your best to go ahead and do that. And then what happens is all the questions build on each other within the main question, as we'll see. So realistically, this is what you have to do. You have to draw above in the shape, plan out what you're going to do for the harder questions, and then simply do it. Simply just follow the calculations, but just follow your plan. It's almost X marks the spot on these. Okay, great. So let's have a look at this first one here. Question 7.1. It says a rectangular parade ground is 10 meters long and 7.5 meters wide, as shown below. Grant. A vertical flagpole stands in one corner of the ground. From the opposite corner, the angle of elevation, so remember the looking up angle of elevation, if we had our clinometer looking up, the angle of elevation to the top of the flagpole is 17.74 degrees. Grand. Leaving cert higher level maths, bringing in like decimals and degrees, not a problem. Calculator will take care of it. Find the height of the flagpole. Okay, so what we have to do in this question is find this height here. So that's what I've gone ahead and I've tried to draw on the board. It might be easier for you to look at your diagram down there. Okay, my absolute reflex, before I even go ahead and look for H, I'm going to draw this piece again as if I'm looking at it from above. I'm up top, looking down on this flagpole coming up from this, playground or whatever it is. Okay, so what I'm going to do is what I see down at the bottom is actually a rectangle. Okay, so that thing on the bottom is a rectangle. If I didn't spot it there, they actually say it. So we've got 10 and we've got 7.5. I'm actually just going to get rid of meters until my answer there. I would always draw the line across here to remind myself that we got some Pythagoras probably going on. And then I'm going to draw the triangle containing the piece, containing the side that I'm actually looking for. And this is quite straightforward in this one here, because you can see we've got a flagpole going on there. So if I go ahead and I draw that triangle here, we've got H is what we're looking for. We've got this is 17.74. That was given in the question. Grand. And nothing else. Okay, so you may remember that actually filling out triangles, we need at least 3 pieces of information. We need, like in this sort of case, we need a right angle triangle. We need to know it's a right angle triangle and 2 more pieces of information. Or in a non-right angle triangle, just 3 pieces of information between sides and angles. So currently, if you look at this triangle in this form, I cannot find H. There's nothing I can do to find H. I don't have enough information. However, as is usually the case, if you look at the piece from above, there is a piece of information that we can get from the base that can then transfer into our triangle. And that piece of information is quite straightforward. That's that dotted line I have there. That dotted line is actually the base of our triangle. So if you see it on that diagram there, that's just this part, which then subsequently is this part here. Okay, so I've drawn it out. I'm going to plan. So what I'm going to do is I'm going to get X. I'm going to call that X. And once I get X, that helps me jump into this triangle over here. And then suddenly I'll have 1, 2, 3 pieces of information, and I can get H. And now all that's left is to go ahead and do that. Okay, so if I go ahead and do that, I'll do it up here. So just looking at this right angle triangle, using Pythagoras, because I have 2 sides looking for a third, I have that X squared equals to 10 squared plus 7.5 squared. And then I got that X equals to 12.5. Obviously you have all the solutions if you wanted to go through that step by step. Don't forget to square root your answer here. So X is 12.5. And now I know that this is 12.5. I'm just going to deal with this triangle. And if you wanted to go through your motions, is it a right angle triangle? Yeah. Does it have an angle? Yeah. So we're going to go ahead and use SOHCAHTOA. Just to remind you about SOHCAHTOA, if you wanted to follow the 4 steps that actually never fail, they're at the start of your handout. You can label it. So you go to the angle in the question. The side opposite is the opposite. The side across from the right angle is the hypotenuse. And the last side, this X, is the adjacent. You decide which one you're using. So in this case, because we have X, or because we have now 12.5, the adjacent, and because we're looking for H, they're the 2 we want to use in the question. Okay, so adjacent and opposite in terms of SOHCAHTOA. That stands for tan is opposite over adjacent. So tan is the opposite over the adjacent. Grand. Now if I fill in my numbers from the question that I have that the tan of 17.74 degrees is the opposite, which is H, over the adjacent, which is 12.5. If I multiply both sides by 12.5 and put it into my calculator, that will give me an answer for H. And I found out that H, can't find my red pen, but I can find out what H is there too. I should get a holster, you know. Hold on. Okay, so then I find out, if I multiply this up here, multiply up by 12.5, put that into my calculator, 12.5 by the tan of 17.74, make sure it's in degrees, you should get an answer that H equals to 4 meters. Okay, now I'm not massively interested in the junior cert stuff, I know you're okay with that, but I am interested in the actual planning of it. So again, what were our steps? We draw it, as in we draw it from above and we draw the shape we're looking for. We make out our plan, like I've done here, and then you go ahead and do it. And the actual doing of the plan, as you can see, is very, very, very straightforward. In loads of the trigonometric questions that come up on the Leaving Cert, and as we're going to see over the next couple of videos, there's actually not that much maths in it, but you definitely have to spend probably half, sometimes even 3/4 of your question planning it out. And that's the trick. A lot of students just jump into it and then can't do it and get bogged down in what they don't know. We've got a plan, we're going to stick to it. So we draw, plan, and do. Okay, if you turn over the next page, there's a question to do with a cuboid. Okay, so on page 49 here, I've attempted to draw the cuboid up there. It's genuinely probably the best one that I've ever drawn in my entire teaching career, and it's still absolutely terrible. So again, you should probably refer to this down here. But it says the diagram below shows a cuboid. Okay, not even entertaining the rest of it. What I'm going to do is I'm going to draw it from above to begin with. Okay, so if I was drawing it from above, if this cuboid was see-through and I could see its base down here, I would know that this is E, H, we've got F and G here, and I would draw a line across there like that. So I know this is 10, and I know this is 6. Okay, cool. Nothing else. Probably going to get this, but we'll leave it for a second. We'll read the question. It says, you are given that GH is equal to 10 and FG is equal to 6. Grand, so we already knew that. And the total volume of the cuboid is 300 centimeters cubed. Okay, the volume is 300 centimeters cubed. It says find BF. Well, when I was actually at Johnstown Primary School, I was in a prefab, and I remember Mr. Michael Donnelly taking us out to measure the length and the breadth and the height of the prefab so we could learn about the volume. And that was genuinely when I was 12. Okay, so this question we answered by a 12-year-old, maybe 11. So it's nothing complicated again. Like in our last video, you might think, oh, what the hell? What's going on here? It's just to get you into it. And this piece of information turns out to be crucial. Okay, so we know that the volume, and we probably don't even have to write this down, the volume is equal to the length by the width by the height. Okay, we've got told the volume is 300. We've got two of the sides here, and we're looking for what? BF. We're looking for this height here. So we've got two, looking for the third. There's the two that we have. Grand. So that's equal to 10 by 6 by, let's just say, y. Grand. And then if you multiply these two by each other and divide across, you can find out that y equals to 5 centimeters. And that's probably going to be pretty important for us in the future. So what I would do is I'd go back to my 3D piece and I'd write the 5 there. Okay, cool. So that first part, really, really easy. Then it says show that BH is 12.7. So show that BH is 12.7. All right, so first things first, it says show and gives you the answer. I don't like when the examiner does that because that encourages students to use the number they've given you in the question, and you can't do that. What that's saying realistically is find BH, and the answer is this. That's what it's saying. So it would be easier for you if it just said find BH. You would not get confused by that. Now, what is BH if I have a look here? So BH, BH. Okay, so this is going to be quite hard to see in your diagram, but if you took a pencil and you go from the bottom left corner up to the top right corner, that's BH there. And that's potentially a little bit tricky if we didn't have our rule. Let's go ahead and take that BH out. So there's BH. Let's try draw the triangle that's actually in. And hopefully you can see it's actually the same shape as we had over here for our triangle. Okay, it's the same shape. BH is the diagonal line going up. So I'm going to turn that into a right angle triangle. It might be hard to see it on my diagram here. You don't have to draw it in the 3D diagram. But that's what I'm dealing with. And then we've got a line across the bottom there. Grand, what do I have from this? Well, I know this side here is 5. And that's actually all I know, and I'm looking for BH. Okay, so that's a little bit awkward there for us. Okay, so what I would ask you to do now is stop the video and go ahead and see, can you give this a shot? See if you can go ahead and sort it out. Okay, if you stop the video, what I hope you have, first of all, is drawn these pieces and then made a plan. So what's your plan? Well, if you look at this here, we've got B, we've got F, and we've got H, grand. And now straight away I can see the plan. The exact same as the last one over there. If I find this dotted line here, which I can, because that's the one that appears time and time and time again, and I get the answer, let's call that X, and I put that X in here, because there's HF as well. That triangle's like slotted on top of that, almost like some sort of Kinex or Lego or something like that. Well, then I can go ahead and find what I'm looking for, which is this BH here. So let's just call that Y. So there's my plan. I'm going to get that, sub it into here, and then be able to work on this triangle. and it actually is going to be solved again using Pythagoras. So if you use Pythagoras and you find x over here, you should figure out that that part. So we've got x squared. So we've got x squared equals to 10 squared plus 6 squared. Grand. So we've got x squared equals to 136. So x is equal to root 136. Fine. You don't have to turn that into a decimal. Let's just put it here. There's our root 136. And if we go ahead and use Pythagoras for the second time in this leaving cert question, we will be able to find that, okay, y squared equals to 5 squared plus 136 squared. And if you tidy that up and put it into your calculator, you should find that BH or y is equal to 12.7 centimeters squared. So that's it there. Okay, so as long as you have a plan, it should be okay. It should be fine to go through. The maths takes a second. The plan is what's important. So that's why I asked you to stop it and give it a shot. If you didn't stop it and give it a shot, what I'd like you to do is actually just take a piece of paper and try those 2 questions again. Make sure you can plan it yourself. Might be easy when you see me do it, but make sure you can plan it out yourself for that. One more thing I would say, just to make sure you're okay with this, that remember this, if we're using Pythagoras as c squared equals to a squared plus b squared, we aren't always looking for the c, not all the time. So remember, our c is always the one across from the right angle. So in this case, we actually just did it twice. However, in other cases, we might not. Okay, moving on with the question. Then it says part 3. So we still okay with this side of the board? Yeah? Alright, so moving on with this part 3 here, it says find angle BHF. So BHF. Now you don't have to draw the triangle out again. I'm going to do it up here. But if I draw it out one last time, we have right angle BHF. We know this is root 136. Should we just found this is 12.7, and we knew for a while that this was 5. Actually, that was our very first start to the question. And they're looking for angle BHF. Okay, so 2 ways of looking at this. You could say BHF, so we want this angle, or it's at the middle letter. So sometimes in complex numbers, which we're going to see in a few weeks, it's not as clear, so some people like to go for the middle piece. Okay, let's just call this whatever you want. I know we've used x and y again, let's just call that x. So you ask yourself, is it a right angle triangle? Yeah. Is there an angle in the question? Yeah, well actually that's what we're looking for, so it's SOHCAHTOA. You follow your SOHCAHTOA principles. I'm going to use sine just because I'm used to it, and I can say that the sine of x equals to the opposite, which is 5, over 12.7. And if I go ahead and solve that, inverse sine both sides, x ends up equaling to 23.2 degrees. Okay, part 4. So part 4 says find CH. Okay, so let's just get our bearings again. Where's CH? Okay, so CH is actually on the front. So it's actually on the front of this cube here. So if I rub out this red line that we had before, which I have the luxury of doing, and you guys could maybe rub out that pencil to see it, but that's CH here. So actually the front part of that cube, find that. Okay, that's actually remarkably straightforward as well once you notice it, because look, there's a right angle triangle. They're just asking you about a face of a cube. Okay, Rob will kill me for doing the right angle like that. Don't tell him. Okay. Okay, so there we go. So we got this piece here. What do we know about it? Well, if you actually redrew that triangle, so what number are we on? We're on that. Okay, so we redraw that triangle there. Well, right angled, we've got that this is 5, we've got that this is 10. So again, it's just Pythagoras for what, the 3rd time in this question? If you do Pythagoras there and you figure that out, you'll find that CH equals to 11.2 centimeters. Okay, and the very, very last part here, this is a challenging part. This is very, very hard to spot. But it says, find angle CBH. So find angle CBH. Now I'll find this very hard to draw this on the board, but CBH. So here to here and then the triangle that goes down here. Like, what does that even make? What sort of shape is that? Okay, it's quite hard to see. So I'm going to rub it out, this part out here, and I'm going to draw it underneath. So CBH. Well, if you actually think about it in your mind, so you could draw a way better triangle than this. It looks like a bow and arrow or something. If you think CB is the base of that triangle. Okay, there's a line somewhere going in the back there that's going to attach with H, but CBH. Okay, so you think CB is the base. So there's CB. Okay, cool. And then it's coming down and it's hitting H. We know CH, so let's just go up there. So we've got CH and B, and there's that line down the back that we can't really see. Well, that's actually a right angle triangle. There, I did it again, sorry Rob. Okay, that's actually a right angle triangle. We know some of these answers here. We've already gotten some of these answers. So we just got that CH was 11.2 in that part there. Okay, so CH is a 11.2. Grant, and that's why they asked you to get it. Okay, what else do we have? We have that CB. Well, because we've got GF here, well, CB must be the same, so that's 6, so therefore that's 6. And even if it doesn't look like it on my piece there, and they ask you to find angle CBH, so we're looking for this. Let's just call it Y. Okay, is it a right angle triangle? Yes. Okay, what are we going to use here? Well, we don't have the luxury of using everything. We don't have the hypotenuse, so we have to use the opposite and the adjacent. So we can say that the tan of Y equals to the opposite, which is 11.2, over the adjacent, which is 6. And if you tidy that up, you should get that Y is equal to 62 degrees. Now, in these questions, I'm not concerned at all with the maths here, because I'm hoping that you have this down. You would have done the work that we said before. I am concerned about the plan. And the plan is looking at it from above and then trying to pull out the triangle. You definitely have a few minutes to do this. You can see the maths will only take a second. Okay, so make sure you're okay with that question. Make sure you're okay with that question there. So a cuboid, quite difficult because there's stuff in the background there, but we've just used Pythagoras and SOHCAHTOA 3 or 4 times each to solve that. Okay, so make sure you're drawing the 2D piece. We're not finished yet. How much time are we at?
22 minutes.
22 minutes. Okay, so there's just one more that I want to do here. And so it's on the next page. Okay, and this is the culmination of everything. Now, you've got the solutions. I'm not going to actually be able to do all the maths for you, but this piece itself, this is a really, really good question. Okay, so it says P is a point on level ground, or is a point with the base of a vertical tree. So straight away I know it's a 3D piece, and I'm going to look at it here. So I'm going to look at the piece that we have, and what I'm going to do is I'm going to draw the triangle from above, which looks something like this. Now, we've no confirmation or not if that's isosceles or not. Okay, that's fine. I'm also seeing that there's only really like 3 other triangles. There's the one with the tree looking like this, and there's the one with the tree looking like this. I'm not going to draw the one at the very front. I might need it later on, but I don't think I do. Okay, so maybe you can see that this base here will be a part of one of the sides, and this base will be a part of the other sides. They tell us a lot of information, so pause the video, read the question, fill in as much stuff as you can. Okay, so I'm going to do that now. So P is 12.8 meters away from OR. Okay, so we've got OR PQ, so OR PQ, so that's 12.8 grand. The angle of elevation of the top of the tree is measured at P is 29.7. So the angle of elevation, if we said that's P, or let's just call the top of the tree T. So we know that this is 29.7 grand. Q is a point on level ground where P or Q is 40.3. So they told us this is 40.3 grand. The angle of elevation of the top of the tree measured at Q is 27.2 degrees. Okay, so this is 27.2 degrees, our other one, so that's Q or T. Grand. And then it says calculate the distance between P and Q. So we want to find this, P and Q. Now they give you a hint. They say hint, find the top of the tree first. Okay, now I'm not actually going to do the maths for you, I'm just going to show you the plan. You've got all the maths in your solutions and you can give it a shot yourself. This is a brilliant question, really, really good, because in the Leaving Cert, the examiner can either give you all the pieces on the diagram, they can give you none, but sometimes they're sly and only give you some of them. So when you look at your diagram there, you can see that they actually gave you some pieces and some were in the question. So if you've not been sure about reading the question first beforehand, well now you definitely should be. Here, if we are actually going ahead and looking for this, let's just focus on this triangle first of all, okay? For me, it looks as a non-right angle triangle. I'm not 100% sure, but I'm quite sure. But it also looks like I'm short a piece because I've got 1, 2, and I need 3 pieces of information. So what's going to happen is something is probably going to be done in one of these triangles to get me a piece of information here. It might be an angle, it might be the side. Okay, I highly doubt it's going to be something, this part here, although it's not the only way to do it the way I'm doing it here. Okay, so that's fine. They have told me that RP is 12.8. So the fact that it's 12.8 there, it's still 12.8 here. That's the same piece. Remember, this is a side going up top like that. So I can't do anything in these triangles here. Fine. But I definitely can do something in this triangle because I got 1, 2, 3 pieces of information. I definitely can't do anything here. But maybe you see what's happening. They said, hint, find the height of the tree first. So this is actually a 3-step idea. Okay, 3 steps. So the plan, we've already drawn it, but the plan is going to be 3 separate steps. If I find the height of the tree here, okay, if I find the height of the tree, so this line here, that's going to bring me into this triangle and allow me to do stuff in here, okay, because now I have this line here, great, so I'll have 1, 2, 3 pieces of information, okay. From that, I can then find this line here, or Q, which is brilliant. I can find or Q, and that or Q is the same or Q here. So that will bring me back into here, and suddenly I have enough information in the triangle that I need. In the triangle they've asked for something in, which was the distance between P and Q, and I'd have 1, 2, 3 pieces of information. In fact, you can even see what rule it would be. Let's just make this up. Let's just pretend that this is 30 grand. So let's just pretend we got it as 30. So 2 junior cert ideas, jump into this. Is it a right angle triangle? No. Is there a pair? No. Cosine rule. A squared equals to b squared plus c squared minus 2bc by the cos of A. And remember, the only thing that you have to make sure you do is whatever angle you use, you got to call the side across from it A. So our x is going to go here. Doesn't matter about which one is B and C. And we make sure we put it into our calculator and then square root it at the end. So give that one a shot. In terms of homework, sure, we have the homework on the board here, sorry. So in terms of homework, we've got 13.9 on page 111, quite like this. So to add to your other questions you got in the last video, 13.9 on page 111. This video is all about setting the idea for 3D triangles. We had, you're always going to draw from above, try your best to draw the shape, mostly right angle triangles. Here's the first idea where it wasn't. Draw, plan and do. Okay, so draw, plan and do. Okay, see you in the next one.